Maximum contiguous subarray problem using divide and conquer strategy. So divide and conquer strategy is when we have a problem, we first try and divide it into sub-problems. Then we try to find the sub-solutions of those sub-problems. When we are done with finding the sub-solutions, we try to merge the sub-solutions into solution. So it is basically divide, conquer, and merge the solution. So whenever we are given with a problem, we can solve it in n number of ways. We have so many strategies to solve the problem. So this is one such strategy, which is called divide and conquer strategy. Now we are going to see how to solve maximum contiguous subarray sum problem using divide and conquer strategy. Now this is the problem. When we have a single dimensional array which may contain a combination of positive and negative numbers, we need to find the sum of contiguous subarray such that we get the largest sum. So I cannot randomly pull some number and then find the sum, right? So picking this 6 and then 1, 5, 6. That is not contiguous subarray sum. Okay, it should be in sequence, contiguous array. Then only I say that it is the maximum contiguous subarray sum. So that is the problem. Now, if we use the naive method, what happens? We first choose the first item and say that that is the maximum sum, and then we try to add each and every other element in combination and then find out which is the maximum sum. So when we do so, the time complexity is of the order of n square. Now we are going to use divide and conquer strategy, and then we are going to bring down the time complexity. So when we do so, the time complexity is going to be order of n log n. Now, we need to know three terms when we are going to solve maximum subarray sum problem using divide and conquer strategy. So the first one is left subarray sum, then right subarray sum, and crossing subarray sum. So now what I'm going to do is I'm given with an array of numbers. I'm going to divide it into halves. Now I have 8 elements. I'm going to find the mid element and then I'm going to divide it into two halves. So I have 8 elements, right? So the midpoint is at -2. So I'm going to divide the array just after -2 here. So when this is happening, now what is the main agenda? I want to find the maximum subarray sum. So as I divide it, I'll be getting two subarrays with 4 elements each. Again, this is a problem. I'm going to subdivide it into halves. So because I have four elements each, I will be dividing at the midpoint, right? So I'll be dividing it here. So I get two elements each. Now I have two elements in each subarray. I'm going to divide it into the smallest individual unit, which is 1. So I'll be dividing it into single items, right? Now, as I told, we have to consider left subarray sum, right subarray sum, and crossing subarray sum. Now, from this individual unit, all I need to do is find out the most, uh, you know, greatest subarray sum. So when I only have one element, then the LSS, which is left subarray sum, is going to be -2. My right subarray sum for this array is -5. So it is called RSS, right subarray sum. Similarly, here the left subarray sum is 6, right subarray sum is -2. Here the left subarray sum is -3, the right subarray sum is 1. Here the left subarray sum is 5 and the right subarray sum is 6. Now I have to find the crossing subarray sum. Crossing subarray sum is the combination of the left and the rightmost midpoints. So here the midpoint is the leftmost item and mid plus 1 is this item. So the crossing subarray sum, which I say CSS, crossing subarray sum is -7. Here the crossing subarray sum. Crossing subarray sum includes the midpoints, and then it can add any element, any number of elements to the left side and any number of items to the right side, such that it is bringing the maximum value, maximum sum. So here the crossing subarray sum is the addition of these two elements, which is going to be 4. Similarly here the combination of these two is 2, -2, and here it is going to be 11, right? Now when I pass the left subarray sum of this 4 element, I'll pick whichever is the maximum. So I have -2, -7, -5. The maximum value that can be passed is -2, because -2 is maximum of -2, -7 and -5. Here we have 3 values, 6, 4 and -2, and the maximum value that can be passed is 6. Here we have 3 values and the maximum value that can be passed is 1. Here we have 3 values, 5, 11 and 6, and the maximum value that can be passed is 11. Right? Now, let us take this subarray and find out which is the crossing subarray sum. So crossing subarray sum, I have to take these two values, okay, and then I can add any element from the left or from the right such that I'm going to get the maximum value. So when I take this, I have to add these two numbers, which is going to give me 1, and then I can add any element from the left or from the right. So as I add these two numbers, the maximum value that I'm getting is 1. If I add any element from the left or right, it is only going to reduce it. So my CSS is 1. Here, when I add these two numbers from the mid and mid plus 1, I'm going to get 6. As I add this, the value is going to get reduced. So I'm going to take this value, which is 6 plus 6, 12. Now again, find which is the maximum of all 3 values. The maximum of all 3 values is 6. So I'm passing it. Here I have 1, 12 and 11. So the maximum value that I can pass is 12. Now what is the crossing subarray sum? So crossing subarray sum is I have to add these two values first, which is -5. Then I can go this side any further such that I get a maximum value. Similarly, this side any further, which is mid plus 1 to the rightmost point. I want to get the largest subarray sum. So with this, I get -5. I add this 6, so I get 1. And then I have 3 positive numbers on the right. If I take these numbers, it is only going to reduce the maximum subarray sum. So 1 plus 1, 2, 2 plus 11, 13. So which part is giving me the maximum value is the crossing subarray sum. So this crossing subarray sum is generated from this 6 to this 6. So this is the maximum subarray sum here. Let us take another example. So I'll replace this 6 with -6 and see what is happening. Right. So again, let me divide these 8 elements into 2 halves. Again, I have 4 elements each. I divide it into 2, 2. Again, I have 2, 2 elements each. I'm going to divide it into unit elements. Now, here my left subarray sum is -2. Here my right subarray sum is -5. Here it is 6, Here my RSS is minus 2, LSS is minus 3, RSS is 1, LSS is 5, and RSS is minus 6. Now CSS is a combination of left and right, which is mid and mid plus 1. So it's going to be minus 7. Here it is 4. Here it is minus 2. Here it is minus 1. So let us take the largest subarray, largest value. So it's going to be minus 2 here. Here it is 6. Sorry. So here it is 6. Here it is, we have 3 values. The maximum value is 1. Here it is 5. Right. Now let us look for the CSS, crossing subarray sum. So here I need to consider the midpoint and then the mid plus 1. So when I add these two, then I get 1. Here, if I add any more values, it is only going to reduce the crossing subarray sum. So here I'm going to add the mid elements, which is 6. If I add minus 3 or minus 6, it's only going to reduce it. So I'm going to stick to 6, considering mid and mid plus 1. Now I'm going to take whichever is the maximum. So the maximum value is 6. Here the maximum value is 6 again. Right. Now this is the mid, right? This is the mid. So I have to consider mid, I have to consider mid plus 1, and then let me take any values from the left or from the right such that my crossing subarray sum is maximum. So with minus 5, if I'm adding 6, I get 1. If I add any more, then it is only going to reduce my CSS. So I'm not considering these two elements. So for now, it is going to be 1 if I consider 6 along with minus 2 and minus 3. Next, if I add a 1, it's going to increase my CSS. If I add 5, it is going to increase my CSS. If I add this minus 6, it is going to decrease my CSS. So it's going to be 1 plus 1 plus 5. It is 7. So this 7 is obtained only when I'm considering these values. Right? 6 minus 2 minus 3, 1 and 5. So this is the maximum subarray sum for this given single dimensional array. So coming to the time complexity, Naive Bayes method is going to give the time complexity of the order of n square, because we have to take each and every combination. And then when we use this divide and conquer strategy, we are dividing it by half at each step, and then we are combining the solution. So you get the time complexity is of the order of n log n. We have another algorithm which is going to reduce the time complexity even further, which is Kandan's algorithm. But here, why have we taken this divide and conquer strategy for solving this maximum subarray sum problem is in order to understand what is the role of divide and conquer strategy. So there are maybe each and every day we have new algorithms, new research works coming up to reduce the time complexity. But this is one standard strategy to solve maximum subarray sum. And divide and conquer strategy can be easily understood by taking this problem. Thank you.